Good morning to one and all. I am Kalpana, Assistant Professor, Department of Computer Science Engineering, NPR College of Engineering and Technology. The subject code of this paper is CS8501. Subject name is Theory of Computation. This is the syllabus. So last class we discussed about DFA and its examples. So in previous classes we recall about introduction to formal proof, additional forms of proof, inductive proof, finite automata. There are two types of finite automata: deterministic finite automata and non-deterministic finite automata. And last class we see the example of deterministic finite automata. Now we are going to recall the definition of finite automata and their types DFA and NDFA with their examples. Okay, finite automata. Finite automata means it consists of 5 tuples. It moves from one state to another state by reading their input symbols. There are two types of finite automata, DFA and NDFA. DFA means deterministic finite automata. NFA means non-deterministic finite automata. The definition of DFA is DFA, it has single transition from one state to another state for the same input symbol. I will explain with example. Here in this diagram, the input alphabet is summation 0, 1. For the input 0, it has single transition from one state to another state. For the input 1, it has single transition for the one state to another state. There is no multiple transitions for the same input 0 and 1. So this is the example of DFA. But in NFA, we have more than one transition for the same input. But in NFA, we have more than one transition for the same input. Here, input is alphabet 0, 1. Here, Q0 has zeros. That is more than one input alphabet. It can be moved from one state to another state. That is the difference between DFA and NFA. In DFA, we have single transition for the same input. But in NFA, we have more than one transition for the same input. Each and every state has start state and final state. Here start state is Q0 and final state is Q3. So this is the basic difference between DFA and NFA. Let me come to the definition. In NFA, when compared to DFA, in NFA also we have 5 tuples, that is Q, summation, del, Q0, F, where Q is the set of states. Here there are 4 states, Q0, Q1, Q2, Q3. So this is the set of states. It can become under the category of Q. And summation means input alphabets. There are 2 alphabets in this given transition diagram. One is 0 and another one is 1. So input alphabet is 0, 1, and del represents transition function, that is input move from one state to another state. For example, Q0 moves to Q1 for the input 0. Q0 also move to the same state Q0 for the input 0. So this is transition function, how the input is processing from one state to another state, where Q0 is considered as start state and final state. Here Q3 is considered as final state. So this is the definition of NFA. Now we are going to see the example problem for NFA. Question is, design an NFA for the input 1010 over the set 0, 1. Here the input given in the question is 1010. So we have to draw transition diagram as well as transition table for the same input 1010. So before that I am going to write the given data. First, the definition of NFA is Q summation del Q0 F. So for every problem you have to write the definition first, and then for every problem you have to write the definition first and write the input given in the question. Here the input given in the question is 1010, and we are going to draw the transition diagram and transition table for the input 1010. Here the transition diagram for the input 1010 is, the input is 1010. So Q0 to 1 0 1 0. So this is the diagram. But according to the question NFA, we have more than one transition for the same input. So that's why I am include extra 0 here. So I will write here Q0. You can draw like this also. 1 0 1 0 1 0. Here it is start state, here it is final state. This is the diagram for DFA. But now we are going to draw the diagram for NFA. So NFA represents more than one transition for the same input. So I am adding extra 1 here. It's your choice, you can add one more 0 or one more 1. Here I am adding extra 0 here. So this is the concept of NFA. So same concept, I am drawing diagram here. So the input is 1 here, 1 0 1 0. According to concept of NFA, I am adding extra 0 here. And now draw the table for this above diagram. First write the states. States are represented as column and inputs are represented as rows 0 1. Q0 to 0 process to Q1. Q0 to 1 process to the same state Q0. And second Q1. Q1 to 0 passes to Q2. Q1 to 0 again passes to Q1. Q1 to 0 passes to Q2. Q1 to 1 passes to the same state Q1. Then Q2 to 0, no input. Q2 to 0, 1 and also no input. So this is the transition table for the above diagram. And when coming to the transition function helps us to check the input is accepted or not. The same formula for transition function, but here we have more than one inputs. We have to represent the more than one inputs. The formula for transition function is del of q comma a w del cap del of q comma a comma w, where q is the starting state and a is the first input and w represents the remaining input. For in this example, here the input is 1010 and the starting state is Q0. So write the first state here Q0 comma 1 and write the remaining input 010 here. So you have to check first whether the Q0 to 1 the transition and then write the answer here, and Q2 to 0, like that you have to find out. The last input reaches the final state, therefore we can write the given input is accepted or else rejected. Okay, let me see the example q comma a w. So I am going to write here 1010 because input is 1010. So first we have to find out Q0 to 1. Q0 to 1 process to the input same state Q0. So I write Q0 here and write the remaining input. Insert the first input inside the bracket Q0 comma 0. Remaining input is 10. It is outside the bracket. Q0 to 0. So Q0 to 0 passes to Q1. So write Q1 here and include the remaining input 1 inside the bracket and write the remaining input 0 outside the bracket. Then Q1 to 1 is Q1. Then Q1 to 0. Q1 to 0 is, we have to answer. Q1 to 0 is Q1 comma Q2. So first write Q1 to 0 is Q1 and Q1 to 0 is Q2. So here it reaches the final state. The final state is Q2. So we can write directly as Q2 here. Eliminate the Q1. So when the input reaches the final state, therefore you can write the given input is accepted. So this is first method. And second method is, it is very simple method. Second method. So first write the input here 1010 and start the states from the left hand side. Starting state, write the starting state in the left hand side Q0 and write the remaining input in the right hand side. First check Q0 to 1. Answer is Q0. So write, move the input 1 to right hand side and write the answer Q0 here. Then check Q0 to 0. Answer is Q1. So first move the input 0 right hand side and write the state Q1. Then check Q1 to 1. Q1 to 1 is Q1. So first change the input to the right hand side and write the answer Q1. Then finally write Q1 to 0. We have two answer. One is Q1 and another one is Q2. So here the final state is Q2. So I reject the Q1 here and write Q2. When the input reaches the final state, therefore the given input is accepted. So these are the two methods to find the given input is accepted or rejected for the above diagram. We can check the diagram is correct or not by using this transition function. And next formula is next problem is construct an NFA for a language L which accepts all the strings in the third symbol from the right hand is always A over summation A comma B. Here the given input is A comma B. So you have to draw the diagram based on this input. You don't represent 0 or 1 in this given problem because the given input is A comma B. You have to draw a diagram and mention the input alphabets only A and B for the above problem. Here the condition is third symbol from the right hand is always A. So this this is left hand side, this is right hand side. So third symbol from the right hand is traverse from right to left. So first it may be anything, it may be A or B. Second one is it may be A or B, but the third symbol should be A. So I have taken the input like BA, BA, BA. So for every problem you have to write the definition of NFA, that is Q summation del Q naught comma F, and write the states, how much states you want, and write the input alphabets and del and starting state and final state is Q naught. Here I have taken 3 states. You can take 2 states also here, but in this problem I taken 3 states. Okay. So draw the diagram related to the input. The input is BA, BA because third symbol from the right hand is always A. Okay. The transition diagram. Transition diagram for the input is, so first the input is BA, BA. I have given B here, then A here, B here and A here. According to the concept of NFA, I am going to add more than one transition for any input symbol. So I choose A here because Q0 to A also Q0, then Q0 to A also Q1. Here I add more than one transition for the NFA according to the definition. So then draw the transition table for the diagram. Here Q0 to B is Q0. Q0 to A is, we have two answer. Q0 to A is, one is Q0 and another one is Q1. So write the two answer inside the set bracket. Then Q1 to B is Q1. Q1 to A is Q2. There is no inputs for Q2. If you are given any input like here, you can mention this in the table. If there is no input, mention pi s and no states. Then now it's time to check the input is accepted or not by using the transition function. Start from the left hand side. You have mentioned the state, starting state in the left hand side. So I am given Q0 as starting state. So I mentioned Q0 in left hand side. The input can be represented in right hand side. First check Q0 to B. Q0 to B answer is Q0. So first move the input to the right hand side and then add the state. Answer is Q0. Then check Q0 to A. We have two answer. One is Q0 and another one is Q1. I can choose Q1 because it moves to the next state. So I eliminated the Q0 here. You can choose any one, Q0 or Q1, but it will be repeated again and again. So I taken Q1 as the next state. So B A Q1. Q1 comma B answer is Q1. So first move the input to the right hand side and then add Q1. Q1 to A answer is Q1 to answer is Q2. When the input reaches the final state, the given input is accepted. Here the final state is Q2. So this is the example for DFA and NFA. So again I am recalling the problem with definition. First, for each and every problem you have to represent the definition and write the input. And third step is you have to draw transition diagram for the input. And then based on the transition diagram you have to draw transition table. Finally use the transition function to check the given input is accepted or rejected. So the same example and same concept we followed for DFA. Same thing we have applied in NFA, but in NFA we have more than one transition for the same input. So this is the example of DFA and NFA. Thank you.